Hello everyone, welcome back to the last part of pressure. In this video, we'll be covering the use of manometer to measure gas pressure. Okay, so a manometer looks like this. It's just a tube shape with liquid inside, and then it's usually used to measure pressure difference between both sides of the arms. Okay, and then this is the normal case when there is a liquid inside the manometer, but both sides are not connected to any supply. So initially, the only pressure that acts on surface A and B is only the atmospheric pressure because both of them are exposed to the atmosphere. So the liquid level will flow until they are of equal height or equal depth. So we say that the pressure at A is equal to pressure at B, which is equal to the atmospheric pressure. And therefore, the liquid level at A will be equals to the liquid level at B. They will be of the same height. Okay, but what happens when there is a difference in pressure on both sides of the U-tube arm? Okay, so in this case, you can see that on my left-hand side, which is A, the pressure is greater. That's why it's pushing it down more. So pressure of A is greater than pressure of B. And on this side, my right-hand side, the pressure will be greater because it's pushing down the liquid here. Okay, so over here, pressure of B is greater than pressure of A. Okay, so to measure the difference between the pressure due to the gas supply and the atmospheric pressure, we usually have a manometer set up like that. One side will be connected to the gas. Okay, so this gas will exert a pressure downwards on the liquid, and the other side will be only atmospheric pressure acting on the other side. So over here, you can see that the first step I need to determine is which end has a higher pressure. In this case, the gas pressure will be higher than the atmospheric pressure because the gas pressure is pushing the liquid down, okay, more than the atmospheric pressure. Therefore, the gas pressure is greater, okay, PB over here, pressure of the gas is greater than the atmospheric pressure. Okay, then the next step is how much greater is it? Okay, usually we find a common level. So we find a common level is this dotted line over here. So we know that the pressure at B will be equal to the pressure at C. So the pressure at B is caused by the gas. So the gas pressure over here will be equivalent to the pressure at C, which is everything on top of it, which is atmospheric pressure plus the pressure caused by this column of liquid or this HCM of liquid. Okay, that will be the gas pressure at C, which will also be equivalent to the gas pressure at B. Okay, so let's take a look at more examples. So you can take a look at this. The gas supply is pushing it down by a height of H. Okay, so just take note that the first step, I need to find the common height, which is over here. Pressure at B will be equivalent to pressure at C. Okay, so the next step, I get that gas pressure is more than the atmospheric pressure. So gas pressure is actually atmospheric pressure plus the pressure caused by this height difference. Next, okay, you will see that over here, my gas pressure is less than atmospheric pressure. My atmospheric pressure is pushing it down more. So the atmospheric pressure greater than gas pressure, greater by how much? Greater by this height, H. So over here, I need to find a common line that the pressure is the same, which is the lower line. Okay, is over here, this dotted line. So the pressure at over the left-hand side is the gas pressure plus the pressure caused by the H. Okay, gas pressure plus the pressure caused by this height H is equivalent to over this side, which is the atmospheric pressure. But I'm not interested in finding all this. I'm only interested in finding the gas pressure. So the gas pressure is actually atmospheric minus away the pressure caused by this height because the gas pressure is less than the atmospheric pressure. So it's minus away the pressure caused by this height of liquid. Okay, okay, then let's take a look at more examples. Over here, I have a gas supply connected to one end of the U-tube, and the other end is not exposed to the atmosphere. It's a closed end. So if I have a closed end, it simply means that it's a vacuum. It's not exposed to the atmosphere. There is no pressure over here. So the first step, I need to find a common line. The common line will be, let me do my drawing. The common line will be over here. Okay, so the gas pressure is acting on the left-hand side. Gas pressure will be equivalent to anything that's on top of it over on the right-hand side, which is nothing, plus the pressure caused by height H. Okay, so I'll get my answer. My first answer, the pressure of the gas is the pressure caused by H1. Okay, the next step, okay, again, I find a common line, but now my tube is exposed to the atmosphere, so there is atmospheric pressure. So the pressure of the gas, okay, is the same as the pressure over this side on the right-hand side, which is atmospheric pressure plus the pressure caused by H2. Okay, and the last one, you can see that the atmospheric pressure is pushing it down more. Okay, so I need to find my common height, which is here. Okay, so I'm pushing it down by more by a height of H3. So the gas pressure is lesser than the atmospheric pressure by H3. So the pressure of gas is equal to atmospheric pressure minus the pressure caused by H3. Okay, let's take a look at more examples with numbers given now. Okay, so you have a manometer containing mercury is connected to a gas supply. Calculate the pressure of the gas supply in cm mercury and in Pascal. Okay, so I'm interested in finding this gas supply pressure. Okay, so the first step, I need to identify that the gas pressure is more than atmospheric pressure. So the next step, I'm going to find a common line, which is this dotted line over here. So I'm going to start writing my equation. The pressure at B equals to the pressure at C. Okay. And the pressure at B will be equals to the gas pressure equals to this side at C, which is atmospheric, plus the pressure caused by H, which is 5 cm. Okay, so the pressure of the gas, I will to sub in my formula equals to atmospheric pressure, which is 76 cm mercury, plus this height of the mercury, which is 5 cm, so it will be 81 cm mercury. And if I were to convert it into Pascal, I need to use the formula rho GH. Okay, so I need to change it to meters because it's kg per meter cube. Okay, so I need to change it to meters. So I have density 13.6 times 10 to the power 3 times G 10 times H, which is 0.81 meters. I get the answer, final answer in Pascal. Okay, next question. A manometer containing mercury is connected to a gas supply. Calculate the pressure of the gas supply in cm mercury and in Pascal. So the next step, I'm again going to look at whether this gas pressure is more or atmospheric pressure is more. So in this case, atmospheric pressure is pushing down more. Okay, so atmospheric pressure is more than gas pressure. Okay, so more by how much? More by 10 cm. So the first step, okay, I have already identified is more. So the gas pressure will actually be atmospheric pressure minus away this 10. Okay, or I can use my equation. The pressure at this side will be equivalent to the pressure at this side. I find the common line. So atmospheric pressure equals to the gas supply plus 10. So gas supply will be atmospheric minus 10. So it will be actually 76 minus 10, which is 66 cm. So again, I want to convert it to Pascal, I use rho GH. So 66 cm is 0.66 meters. Okay, let's take a look at another example. Okay, you have the pressure of a gas in a container is measured using a manometer. So the pressure of the gas is found to be 56 cm mercury. Determine the height difference between these two arms, and the atmospheric pressure is 76. Okay, so the atmospheric pressure over here is 76, and this gas pressure is only giving me 56. But I know that this is my common line. At a common line, the pressure must be the same. So what is this extra height over here? Okay, it's actually 76 minus 56, which is 20. Okay, so because over here, if I have 56 cm mercury plus 20, I will be equivalent to 76, which is the same on both arms. Okay, next question. Sometimes question will ask you to find the density of certain liquid using a manometer. So an example is as shown. A manometer contains water in one lane and alcohol in the other. So the water level is 12 cm above the level, indicated by the dotted line X, while the alcohol is at a height of 15 cm above level X. Okay, calculate density of alcohol given that the density of water is 1000 kg per meter cube. So again, in such case, I'm not measuring the gas supply, so I don't need to compare gas supply and atmospheric pressure. I don't need to compare which side of the tube has a higher pressure, but I need to find the common level, the common line where the pressure is the same. So it's always the line that is in between the two different liquids. So over here, in the diagram, the line has already been drawn for you. So at this line, the pressure on this line will be the same. Okay, so at the pressure PA will be the same as PB. Okay, so I'm going to write my first sentence. Pressure at PA will be equals to PB. Okay, so pressure at PA will be equivalent to atmospheric plus 12 cm of water. Pressure at PB will be atmospheric plus 15 cm of alcohol. But since both sides have atmospheric pressure, I'm not going to add in atmospheric pressure in. So I'm just only going to add in the pressure caused by 12 cm of water, which is rho GH 1000. Density of water is 1000 times G 10 times H 0.12 meters, equal to this side. Okay, I don't know what is the density of this alcohol, so I let it be rho. Then G is 10 and then times the height 0.15 cm, 0.15 meters. So I'm able to solve for my density in this case. So my density is 800 kg per meter cube. Okay. Next question, the same thing over here. Okay, I want to find the density of the alcohol. So the first step, I need to look for the common line. The common line is always in between the two liquids. So the pressure at this point will be the same as pressure at this point. So the pressure at the left-hand side is only dependent on atmospheric plus 20 cm of alcohol, while on the right side is only atmospheric plus 10 cm of water. So if I were to write my equation, okay, it will be pressure A will be equals to pressure B. Okay, so pressure A will be alcohol, pressure B will be water. So I sub in my equation. I don't know what is the density of alcohol times 10 times 20 cm, which is 0.2 meters, equals to density of water times 10 times height, 0.1. I am able to solve for my density of my alcohol, which is 500. Okay, next, let's take a look at a little bit more example. For example, I have a tube and I have a liquid stuck in the tube. Okay, there is some gas being trapped here. If there is no gas, this liquid will have dropped all the way down because of gravity pulling this liquid down. But this liquid doesn't fall down because there is some gas trapped over here. Okay, so you must understand that the gas pressure over here will be acting upwards. Okay, let me do a little bit of drawing. Okay, so the gas pressure acting upwards. Okay, but the weight of the tube, the weight of this liquid will be acting downwards. Okay, because gravity is pulling this liquid down. Okay, so in order for this liquid to not move, okay, all my upwards force must be equal to my downwards force. So all the downwards force is atmospheric pressure plus the pressure caused by H will be equivalent to the pressure caused by the gas over here. Okay, next one, what happens if I have a tube being inverted? Okay, in this case, you should understand that this liquid pressure, this drop of liquid will be acting downwards because gravity is pulling it down. Okay, then the gas being trapped inside will also be acting, the gas being trapped inside will also be acting downwards. Okay, pushing this liquid. Okay, so again, in order for the liquid droplet to remain stationary over there, okay, all the upwards must be equal to all the downwards. So atmospheric pressure will be equal to gas plus pressure caused by H. So pressure of gas plus pressure of H equals to atmospheric pressure. Okay, but what happens if I put my tube in this way? In this way, gravity is only acting downwards. So this column of liquid, the gravity is actually acting this way. It doesn't have any effect. Okay, in order for the liquid level to stay over here, for this drop of liquid to stay over here, the pressure of the gas will be equivalent to the pressure of the atmospheric pressure. Pressure of gas is pushing the liquid out, and atmospheric pressure is pushing the liquid in. Okay, that's all that matters. So pressure of gas equals to pressure of atmospheric pressure. Okay, so why are we learning barometer as well as manometer? Because there are many uses. So barometer is often used in weather forecasting. So they realize that if there is a drop in the pressure or a falling barometer reading, it means that a storm is approaching. But if a rising pressure indicates that there will be a fair weather coming. So it's used for weather forecasting. Okay, and then in your aircraft and for your navigations, usually they have a barometer, a digital barometer fixed onto the craft because it is used to provide measurements for the altitude, okay, the height. So for example, you fly an aeroplane going up, okay, as you go higher and higher and higher, the pressure decreases. So by measuring the pressure difference, they use it as a gauge to how high are you flying, okay, above the sea level. Okay, that's it for the end of this chapter.